Identities is what we want to look at. And one of the simplest is what we call the single angle identities. And so we have an example whereby one of the most common angle identities is cos square theta sine square theta is equals to 1. And from that, we can derive other identities from that common angle. The second one we can think about is we write the same, but we divide through by cos squared theta. Plus tan squared theta is equals to sec squared theta. Why did I say so? Because we know that tan theta is equals to sine theta over cos theta. And I also know that sec theta is equals to 1 over cos theta. And with another identity, by dividing through with sine squared theta, this gives me cos squared theta plus 1 is equals to cosec squared theta. How do I arrive at that? What I know is that cos theta all over sine theta is equals to 1 over tan theta, and this is equals to cot theta. That's the first information that I know and I have so that I could use there. And then I also know that 1 over sine theta is equals to cosec theta. So the first identity we want to look at is the sign of A plus or minus B, and that will be sine A cos B plus or minus cos A sine B. And if we think about of an example, for example, the sine of theta plus theta will be equals sine theta cos theta plus cos theta sine theta, and therefore we can comfortably say sine of 2 theta is equals to 2 sine theta cos theta. Now, theta minus theta, which is sine theta cos theta minus cos theta sine theta, and therefore the sine of 0 would also be equals to 0. And we know that the sine of 0 is actually equals to 0. So that is for the sine. What about the cosine? Cos of A plus B plus or minus. Now, for things for the events in the cosine, things are slightly different. When it is positive here, there it's negative. When it's negative here it's positive. And that's what we have there. So that gives me sine A and then sine B. Cos of theta plus theta, and we know that that will be equals to cos 2 theta, and that will be equals to, so A is theta, so it's cos theta, because it's positive, there it's negative, sine theta, and therefore cos 2 theta can also be written as cos squared theta minus sine squared theta. So you can say cos theta of theta, which is cos 2 theta, can be written as cos squared theta minus sine squared theta. You know that cos squared theta plus sine squared theta is equals to 1. Therefore, sine squared theta is equals to 1 minus cos squared theta. So we can also say cos 2 theta is equals to cos squared theta minus, instead of sine squared, you say 1 minus cos squared theta. That's what you could also write. It's not a mass, but this is also a way. And this will give me 2 cos squared theta minus 1. So that is also another way you could have expressed your cos 2 theta. To look at, that is cos of theta minus theta is equals to cos theta plus sin theta sin theta. So we know cos theta minus cos theta is cos of 0, which is equals to cos squared theta plus sin squared theta. What we know about this is equals to 1. And that helps us to see that the cos of 0 is definitely equals to 1. Yes, so the cos of 0 should be equals to 1. Tan 2 theta, I can write it as sine of 2 theta divided by cos of 2 theta. And if that is the case, we know that sine of 2 theta is 2 sine theta cos theta. That one we've already seen. And we know that cos 2 theta from our previous number B above is equals to cos squared theta minus sine squared theta. So that's what we have. And what we want to do is we want to multiply through with 1 over cos squared theta up there, and down here 1 over cos squared theta. So it's like literally I'm multiplying with 1, because 1 over cos squared theta divided by 1 over cos squared theta, that would give me 1. So it's like multiplying with 1. 2 theta is equals to sin theta over cos theta divided by 1 minus sin squared theta over cos squared theta. And therefore, that will give me 2 tan theta over 1 minus tan squared theta. So tan 2 theta is equals to 2 tan theta over 1 minus tan squared theta. Half angle identities. And we want to just change the same angle that we had. We have sine theta. We can also write it as sine of theta over 2 plus theta over 2. And using the principle of the double angles, then we can write this as sine theta over 2 cos of theta over 2 plus cos of theta over 2 sine of theta over 2. 2 sine theta over 2 cos of theta over 2. The same case can apply to the cosine. The cos of theta, which can be written as cos of theta over 2 plus theta over 2. And using the knowledge of the double angles, this will give me cos squared theta over 2 minus sine squared theta over 2.